let's take a look at the Perl scripting language. It is included with the Red Hat Enterprise distribution. We'll launch gedit and open a separate shell using Control-Shift-T to explore where Perl is available in our system. Perl is pretty much standard, stock scripting, and is required for pretty much any Linux, Windows, or any PC-based OS systems administrator. Which Perl will tell you where it's located. It's located in user bin. This becomes very important as we write Perl scripts, as in the header of the script on the very first line, we always reference the location of Perl so that the shell knows how to find the interpreter that's responsible for the script that you'd like to execute. So we're discussing Perl, and it features too many things to list, but we'll just discuss some of the things that Perl can do for you. Perl parses text. It executes programs. It can also function as a CGI or common gateway interface, meaning it can integrate with your web server to process requests from web forms. So web forms, so on and so forth. And it supports regexes, both Perl regular expressions and POSIX regular expressions. So Perl and POSIX regular expressions, among too many other features to mention. It is an all-purpose scripting language. So with that said, how do we actually use Perl to do various things? How do we write basic scripts? Well, let's create a task. Our task is going to be to just simply print hello world. Our first task, that is to print hello world to stdout, or standard out using Perl. A very simple script would resemble the following. We're going to click on new to create a new buffer, and gedit colorizes or supports Perl syntax, and as a consequence will label or colorize the keywords. Whenever starting a Perl script, you include the full path to the Perl interpreter as follows. We included this by executing Control-V, since we copied it into memory. We also use the shebang prefix of !exclamation followed by the location to Perl, the full path to Perl. You may optionally indicate the W option to turn on warnings in the event that you have misused variables or performed other actions that Perl may consider indecent or out of the norm or likely to be misconstrued while processing. So it's a good idea to turn on warnings. There are various ways to turn on warnings. You may indicate the -W option as we've done here, or you may simply indicate use warnings followed by a semicolon. Most lines in Perl, and we'll just repaste that and comment it out, most lines in Perl terminate with semicolon. The very first line, however, is the shebang header, which is required in Perl scripts if you want the script to execute by itself without calling Perl from the command line. Let's proceed with saving this document. And we're going to save it in our test RH5 directory. We'll call this hello world.pl. Once we've saved it as a Perl script, gedit colorizes the keywords in the document. Now, in order to echo anything to the screen, you need to use the print command. So we'll go ahead and print accepts one or more arguments using either double or single quotes, and we'll also print variables with or without those double quotes, but when you use single quotes, it won't print the value of the variable, rather the literal value placed between those quotes. And we'll terminate the line with a semicolon. To print hello world, go ahead and type hello world. But this will print hello world without a new line character. And we'll end the script with a comment indicating that we're done. So this is a simple script to print hello world and can be executed from the shell. Let's go ahead and save changes. This will not send a new line character, however. To execute this script, you can execute using the Perl command followed by the script. the name of the script, which is hello-world.pl. But before executing scripts, it's always a good idea to check the syntax of the script using the -c option. This will tell you whether or not there are any errors or syntactical errors. So Perl-C hello-world.pl checks the syntax of the script, whereas simply Perl hello-world.pl executes the script. And optionally, you may execute the script without referencing Perl explicitly by indicating the full path or the relative path to the script after having flagged the script executable. So if we change mod +x hello-world.pl, and if that succeeds, then execute hello-world using the relative path .pl, we'll be able to execute hello-world.pl without explicitly specifying Perl on the command line. Let's go ahead and try to execute it without checking the syntax using Perl hello-world.pl. Notice it prints hello world, prefixing the prompt, and that's because it did not indicate or include a new line character. So whenever you print items in Perl, you should be aware of that. Sometimes you do want new lines, other times you don't. If you do want new lines, use the escape sequence \n. You may optionally place it juxtaposed to the item that you'd like to print, or using a separate set of quotes separated by a comma as a separate argument to the print function, which we'll show you momentarily. In this case, we've juxtaposed the sequence to hello world. Let's try it from the shell to see how it works. Now we get hello world on a distinct line from the prompt. That's the Linux bash shell prompt. And as we also mentioned, you can do the following, separating the sequence, the \n sequence, from what we'd like to have printed, or the visible characters, since \n will also cause non-printing characters to print. That's a new line character. And this will work just as similarly, or just the same, but the difference being it is more legible, it's more readable. Let's try this from the shell, and it behaves similarly. Now again, to allow our script to execute without specifying Perl on the command line, you need to flag the script as executable. Generally, although we haven't covered permissions, when a file is created in your Linux environment, it is not flagged executable. Case in point, let's lsltr. You'll see that hello-world.pl is flagged as read, write, read, write, read. There are no execute permissions flagged for, or there isn't the execute permission flagged for any of the user group or other permissions. So again, if we change mod, which is a permissions-related command, adding the execute permission to hello-world.pl, it will update the permissions. And instead of using command chaining, let's just change mod and use command chaining with lsltr so that we can see that it has been updated. Now whenever an item's been updated to have the execute bit, the shell colorizes it as using the green color, or the color green. So this tells us or distinguishes hello-world.pl from all of the other entries in the directory, the text file entries in the directory. Now we may execute hello-world.pl directly, and when the bash shell processes hello-world.pl, it will read the very first line, this top line, which includes the shebang header of # exclamation, followed by the full path to Perl with the -w option turned on for warnings. Again, you don't need to memorize any of the options, just run Perl with help, and you'll see that -w enables many of the useful warnings, and it is recommended. Again, if you have reused variables and other things, Perl will warn you about that. Now back to execution of this very simple script. /hello-world.pl causes it to execute without explicitly indicating the Perl interpreter. So we've achieved our desired result for a very simple script. And if you wanted to print multiple lines, for example, go ahead and indicate either in the same print command or on a separate line altogether something else, such as testing Perl 1, 2, 3, for example. This will print a separate line with its own new line character, so each item will be on a distinct line, and there you see it. Now, of course, Perl can do much, much more. It includes modular support, so it is modular, and it can send emails, create spreadsheets, interact with databases, you name it, Perl can possibly do it, or probably do it. So as another task, let's parse regular expressions from the command line using Perl. We're going to have Perl parse whatever we've indicated as argument value number 1 to the Perl script. So second task, parse regular expressions, or regexes, from the command line. So we need to create a script which has the shebang header and expects a value to be parsed from the command line. So we'll go ahead and just copy this header, create a new buffer, and begin a new script. So what would we like to do? Well, again, we want to show you how the regular expressions support in Perl works. Basic regular expressions support works. Since we will be using the argument value array, we will extract the first element from that array, which is going to be the first thing passed in on the command line. So we'll execute our script followed by regex value, which will be stored in an array element of 0 for the array argument value, or argv. So let's set up a condition after having assigned a variable for simplicity. We're going to set var1 equal to arg value, and in between brackets, the element. This is how you reference independent array elements. For example, again, Perl automatically creates the argv variable whenever you've indicated items on the command line. Even when you haven't, it still sets up the variable. And as you specify items on the command line, such as argument value 1, followed by val2, then val3, Perl simply assigns those arguments into the argv array. So to access elements of the array, you indicate the array in scalar form using a $, and open and close brackets, and in between those brackets, the array element, in this case array element 0. We're going to assign this variable to an easier to deal with variable, or much easier to use variable, known as var1. We could certainly use argv bracket 0, close bracket 0, or close bracket that is, in our regular expression test, but it's just a little messier. Now we need a condition to test whether or not a particular regex has been entered on the command line. Again, we're just testing for text that's been submitted on the command line. So now we'll say if var1 equal tilde. Equal tilde simply means is a regex matches the following, then do something. And we've yet to determine that regex. So in the body of this script, we'll say print success, and on a new line, var1 matches, and then terminate with a new line. And you'll see where we're going with this momentarily. Now we need a condition to handle, an else statement to handle if there is no match, else print failure. No match, with a new line. So now we need to determine what the regular expression match will be. For argument value element 0, if we type in something like test, then it should match. If we type in anything other than test, it will not match. And this is a way for you, again, to match against patterns that are specified via the command line, and that is to test the argument value 0 or any argument value. Let's save this document as regex test.pl, and it will colorize everything for us, including the if-else block. Again, before execution, let's Perl-C the regex test.pl, and once the syntax returns OK, we know we're free to proceed. Then we'll change mod +x regex test.pl, and now in the lsltr we'll see that two items have been flagged executable, hello world.pl and regex test.pl. Now when we execute regex test.pl with no arguments, notice it tells us use of uninitialized value and pattern match. So it loops into the else branch, print failure no match. we've specified nothing into var1, and that's why an error has been returned. It's a non-printing character. We haven't specified an item. However, if we went ahead and specified tests, success, test matches. So this works. And if we don't want a space, then we'll just juxtapose it with no space, and everything will line up nicely. So in this case, when argument value 0 is test, we enter the block or the condition section where we print success, var1 matches. Let's print something else. You may now perform actions related to this branch of the code. So this is a way to branch out with your code. Let's try it again. And basically anything that occurs within this branch of the code will take effect. Obviously we're only printing or echoing to the screen, so nothing much appears, but nonetheless we have the ability, we know we're branching properly. This is a great simple test of whether or not your regexes are working. So if var1 matches test, then move forward. Now how about if we specify tests using uppercase? Let's see what happens. Doesn't match. How about mixed case? Lower, upper, doesn't match. In order to turn on the case insensitive approach, at the end of the regex, after the /, the terminating /, indicate the lowercase I option. That turns on the case insensitive match, and now it matches. Any variation of test that we specify will cause the code to enter this branch. You may also include comments in your Perl script, just simply by indicating hash marks. This code block will case insensitively test for a match, for whatever we happen to indicate. We don't need a terminating hash mark here, by the way, but it's just customary to do so. And I also like to indicate multiple terminating hash marks, such as 3, indicating that it truly is a comment. It makes it easy to read. So if the word is test, if it matches, if argument value 0 matches test in any case, then we'll have a match. You can match on anything else. If you'd like, simply change it. You can also search for numerics, such as 0 through 9, using character classes as follows, 0-9, as we've shown you briefly with grep. So if indeed we specify something that matches, such as 1, we have a match. 2 through 9. However, any numeric will match. If we specify non-numeric, such as the following, it does not match. So you can match on numerics. You can also match on alpha and numeric, such as test terminating with 0 through 9. So for example, let's clear screen and try that out again. We'll give this a try with simply test, failure, no match. How about test 1? Test 1 matches. That's because the regular expression match expects the characters test followed by at least one numeric value. How about test 11? Test 11 matches because the regex match matched test and at least one numeric value. If you wanted to match one or more numerical values, you could just leave it as it is or indicate a wildcard such as asterisk to indicate that the previous item should match 0 or more times. If you indicate asterisk, this then means that the item may or may not match. So for example, test now matches because the asterisk means 0 or more times. So notice test matches as well as test 11. And that's because the asterisk juxtaposed to the character class for the numerical values means the numerical value may appear 0 or more times. If it must match, for example, you could use question mark or the plus sign to indicate that the value must be included. So test 11 matches, in this case, test matches, and this is for 0 or 1 time. If it must match, you use the plus sign and try it out, and it says failure no match, but if you put a number, it matches. So this tells us, and we can include it here in our code, that asterisk equals 0 or more matches as far as regular expressions are concerned. It also tells us that the question mark means 0 or 1 match. And it also tells us, because we've used another meta character, that plus means 1 or more matches. So we have some flexibility using standard POSIX compliant regular expression meta characters to determine exactly what we're searching for. We want values that resemble the following, TEST, and we need at least one numerical match in order to move forward. Otherwise, the match is a failure. Let's just cover that again. We'll run it with simply test, which has no numeric value, and we fail to match because we're now using the plus meta character, which juxtaposed to the character class 0 through 9 means we must have at least one numeric match, which means if we indicate test 1, it works, it matches. Test 1, 1 matches. Test 9, 9, 9, 9, 9 matches because we have at least one numeric value. Changing the plus, however, to a question mark means 0 or 1 match, which means test 9999 matches, test 11 matches, test 1 matches, but how about simply test? In this case, test matches because, again, question mark means 0 or 1 match. If you need 0 or more matches, use asterisk. Asterisk means that it may or may not be there. So let's try it with test now, and you see that it matches. Test with any series of numbers will match. So this is one way you can include meta characters, and this also works with grep. You may also indicate how many of the previous character class or set of characters must match using ranges in between curly braces. So for example, we could say that we want to match at least 2 and up to 5 numeric values by juxtaposing the curly braces to the character classes. And then, if you have at least 2 up to 5, it works. But notice when we have only one numeric value, it fails. Let's try 2 numeric values. Succeeds. 3 succeeds. 4, 5 succeeds, and it succeeds up to the level that we expect, 2 up to 5 characters. If we go beyond the 5 characters, however, the 5 numeric characters, it fails. So this means we can indicate a range. So min, comma, max equals match minimum up to maximum for previous regex. Now, with that said, a regex represents any characters that you'd like to match. It isn't simply a character class such as 0 through 9 or an escape sequence to represent white space. It can be anything, including string literals. So we should just note that. And we need to comment it, of course. Regexes include, but are not limited to, string literals, escape sequences, and meta characters, etc. These are the primary items that constitute. Let's just ensure that these items are on the same line, line 11. These are the primary items that constitute regular expressions. String literals such as TEST, escape sequences such as \n, meta characters such as asterisk, plus sign, question mark. We should also include character classes such as 0 through 9 or A through Z. So for example, our TEST, we could have indicated A through Z to indicate that we need at least one alpha followed by n number of numerics. So let's try this with T1. T1 doesn't match. How about T12? T12 matches. Let's take a look at why T12 matches. We need at least one alpha, A through Z, and we need 2 up to 5 numerics. If we drop this, or make it 1 up to 5, then the previous attempt would succeed for T1. So again, at least one numeric, or one alpha, and at least one numeric up to 5. If you want to enforce a certain number of alpha characters, then use the ranges we've mentioned, such as the following. 4 up to, let's say, 9. This means that we'll accept TEST or any alpha sequence that has at least 4 characters. And it starts to get messy. It starts to get a bit hard to read, but if you follow it slowly but surely and note that curly braces apply to the previous item and other meta characters like plus, question, and asterisk apply to the previous item, then you can follow it. So now if we try T1, notice failure no match, because T1 represents one alpha character. We need at least 4. Let's keep building this up to see how it works. We'll try TE1. Still no match, because again, TE represents 2 of the 4 required. And we'll just keep building. TES. Still no match. 3 alphas, 1 numeric. 1 numeric is fine, but we need at least 4 alpha, or alphas. How about TEST? TEST matches, because we have 4. We cannot exceed 9, however. 9 alphas, we mean. We need at least 1 numeric, up to 5 numerics, which means test 15 will work, 16 will work, or 156, 1567 will work, to cause the conditional block to branch into the branch that we'd like. And hey, if we have a failure, no problem. There's a branch to handle that failure as well, and you can do what you'd like in the failure section, such as printing, calling functions, failure no match, please execute error handler here. So it's not a problem whatsoever if you don't have a match. You simply need to know how to handle when you don't have a match, such as TES11 or 111 generates a failure no match because we've branched into a section where the regular expression that we've typed or included no longer works. Now you may also represent your regular expression using a variable. That's something we should also note. Note, regexes can be stored in variables. So for example, if we set, and the way you set variables in Perl is very simple, either indicate my followed by var name, or simply indicate the var name. If you indicate the var name without my, then the variable will be accessible to all functions, all calls throughout the entire script. My localizes it to the region. So my, and this becomes very useful when you start to include code from other scripts. My, for example, regex match 1 is equal to, in between single quotes so we don't lose any meaning, everything you see here. Take this out and paste it here. Now we've got our regex independent of the test of the regex. And in between the regex tests, we can now reference the name of the variable, which is simply regex match 1. So this is a way to abstract your regular expression and to keep it nice and neat from the actual test area, giving you some room to breathe and to test and to work on your code. So let's go ahead and give that a try. We've saved it. We'll clear screen and then use Perl's syntax checking function to ensure that we haven't clobbered anything. And all looks well so far, meaning there are no syntactical errors. Syntactical errors include forgetting to terminate a line with semicolon, unless it's the opening of condition sections such as if, else, else if, so on and so forth, and missing quotes, single quotes, unterminated regular expression matches, you name it. /regex test TE1 fails, failure no match. TES1 fails, again no match. However, TEST1 succeeds up to n number of numeric characters. So again, we've barely scratched the surface of what you can do with Perl. We've quickly shown you how to print hello world, which is a standard program, which means you know how to set up a Perl script. We reference Perl in the shebang header using # exclamation, the path to Perl, and you turn on warnings. We then set a basic variable var1 to argv element 0, which includes the first item we type on the command line. If you also want to perform matches or do things with other values, such as argument value number 1, 2, 3, 4, and so on, then simply set up variables or handle argvs 1, 2, 3 to n. Then we've also shown you how to write a regular expression which searches for a certain number of alphanumeric characters, as well as how to test them and to branch out your code. So that's a little bit about how you use Perl to do things. Let's move on to some other things you can do with Red Hat Enterprise Linux.